Okay, so hi everyone. My name is Thiago Holleben. I'm a PhD student in Canada, studying with Sarah Faridi. I just said this, but here it is again. Um, so I think everyone in this room has played dominoes. If you haven't, the idea is that you have these rectangles that have like numbers on both ends, and you want to basically match the numbers on both ends when you put the dominoes down. We can abstract that idea, and instead of having dominoes that are like rectangles, we can think of them as just line segments, okay? And then the idea of playing dominoes is you have some line segments, and you want to glue more line segments at the endpoints of the previous line segments, okay? So my research, what I do, I think almost all of it, is basically studying generalizations of this. So instead of looking at line segments glued at endpoints, like gluing line segments at other endpoints of line segments, you can have, let's say, triangles that you glue along edges, or you could have pyramids that you glue along triangles, and so on. You can go up in dimensions, okay? Now, it turns out that if you play dominoes in the correct dimension, so if your pieces are two-dimensional and you're playing in 2D, which is not what we usually do, we play dominoes with one-dimensional pieces in 2D, so that's the wrong dimension. But if you're playing the correct dimension, what you get, if you look at the board, so like the pieces that have been laid out, is a triangulation of a manifold. Unless you're playing with someone really good, but we can forget about that. So these triangulations of manifolds, they actually appear in many areas of mathematics. So for example, they're very useful in differential geometry, in metric geometry, algebraic topology, commutative algebra even, and so on. And the questions that I'm interested in terms of like these triangulations are basically enumerative questions. So given such a triangulation, how many pieces did you use? Given the number of pieces that you used, how many edges do you have? Given the number of pieces, how many vertices do you have? Are these numbers related? Is there like any equality that they must satisfy? One famous one that we know is Euler's equality. Okay? And the cool thing that I like to do with them is you can take one of these triangulations and you can associate objects in other areas of mathematics to these triangulations. So you can associate, let's say, polytopes from discrete geometry. You can associate rings to these objects. And once you do that, it turns out that if you take a complicated triangulation, you can end up getting weird behavior on the other area. So things that people do not expect to happen in, let's say, commutative algebra or discrete geometry, you can get those examples by looking at these weird triangulations and the objects that you get from them. Okay?